right, so I thought maybe the best thing to do is to get you through these applications. Certainly you can write this problem down first and then maybe try to work it on your own. So don't sneak at the answer, but the very first problem is just simply asking you to find all intervals where the function is increasing or decreasing. And I think right away, increasing, decreasing, that's derivatives. So if a function is increasing and then it hits 0 and then it decreases, I can see that there would be a critical point there. And then of course decreasing hits 0. And what I'm saying hitting 0 is the derivative, right? So that's what you're looking at. So if I take this first derivative, bring the 3, this is just power rule. This is a really nice, easy one. And then I set the equation equal to 0, is what I'm doing right here. And I can find my critical points. So this is never going to equal 0, the negative 9. I said x squared minus 9. I factor it, and I get the plus and minus for my 2 critical points. Then you have a choice. You can either use the number line method or you can use the second derivative. I like the second derivative better, but that's up to you. The number line method, remember, you write out your critical points, and then from here you pick values in, below -3 in these intervals. I couldn't think of the word interval. And so you plug these values that you're picking into the first derivative, okay, and if you get a negative number, which I did, it's decreasing. Of course, at a critical point, it's at 0, so it's flat, increasing, and so on. The second derivative, I think, is easier for a function like this. So the first derivative, negative 9x squared plus 81. The second derivative would just be negative 18x. And you plug your critical points into, I'm sorry, that's an ugly CP. You plug your critical points in here. All right, so, and this is how you write the actual increasing, decreasing. Here is just, I think this is a different one, yeah. Here is just a second example. Again, you can pause, and try to work this out, because these might be different than yours, give you a lot of good practice problems. All right, question number 2 says find the global max and min. So max and min. So my brain goes, I bet I should take a derivative, and I bet this is the product rule. But then my brain goes, but this is also looks just like the surge function. So you'll get the same answer either way, but in this case, I'm going to be lazy, and I'm going to use this actual surge function, which is the 1 over b. Remember, the b is that number, is that number right there, okay, that 8. And so 1 over b, 1 over 8 ends up being my max. And how do I know if it's a max or a min? I plug values to the left and the right. You would not be wrong by using the product rule, but you would be wasting your time, hence, on a test. All right, question 3, inflection points. Inflection points, remember, is where the function is increasing or decreasing the fastest, and where it's where it's changing from like concave up to concave down. So you can see my picture here with inflection points. Inflection points are found with the second derivative. You should have that written in your notes. Inflection points, the second derivative equals 0. So I take my first derivative, then I take the derivative again, and I'm going to set this equal to 0. I factored out a 6 because algebra is hard to factor. Algebra is just hard, right? Yeah. And so now I actually solve these and I get my inflection points. Here is, I think this is a different, it might be the same example. No, it's a little different. Here's a different example, but again, kind of factoring out the same thing to find inflection points. All right, question number 4, I get asked this the most. So when students start posting in GroupMe, how do you do question 4? Say, did you watch Cindy's video, please? So how you actually work this, so it talks about given by this, maximize, that's got to be a derivative. And then when you maximize the temperature change, you're taking a second derivative. So this piece right here, I'm just rewriting. And then what I did is I distributed the d squared out. and then I set this equal to 0. Well, I'm sorry, I take the derivative of it. So the 2 comes down, those are going to cancel, subtract 1, the 3 comes down, the 3's cancel, subtract 1, and then I set just this top piece here equal to 0, and in this case I can see I need to solve for D, and I get my answer of C. The same thing for part 2, now you're just taking your second derivative, so you're taking the derivative of that, and you're setting that equal to 0. Again, that's kind of just a crazy worded one, but it's actually pretty easy once you see how to do it. Question number 5, your favorite, the quotient rule. You think I don't read your discussion questions. I see. I hate the discussion rule. It's too many steps. Okay, whatever. So take the derivative of the top, leave the bottom alone, minus leave the top alone, derivative of the bottom. Remember, we don't really care what's on the bottom, because if you set this equal to 0 and you multiply this on both sides, it's just going to go away anyway. So you set the top equal to 0, you go through all your steps to solve for your variable, and then once again I did in this case I did do a number line, because the second derivative you would have to take all of this, and you hate quotient rules, so why would you do a quotient rule twice? Alright, another one that I get asked a lot about. This is a table, and notice the first part that it's telling you estimate the x values of the critical points, and this first part is telling you that, for example, that this is the function. The second one comes back and says, oh, now let's pretend that this is derivatives. What I do is, these are just points. Why not go into Desmos? You know, you can plot in a table very quickly every single one of these points, and I can see where the critical points, the min and the max are. Okay, notice how you have to put your answers in here, all right, for the min and the max. Another thing students start to notice is, notice it's going negative, more negative, and then it turns. I mean, these are the things that students kind of see. Notice that this, and I'm looking at this line here. So notice here, this is up above, right? And then it's, and then it's turning to go down. Okay, from 1 to -1. I'm looking at the y values, is what I'm looking at, or you graph it. Now that we're saying these are derivatives, so instead of y, this is now y prime. This one's probably a little easier, but again, you could graph it. But in this case, anywhere it changes, notice from a positive to a negative. So a positive value to a negative would be a max. Also notice how you have to write these answers in the 0.5s. All right, okay, so that'll get asked a lot too. All right, number 7, this is just flat out find a global max and min, nothing really new, different there. All right, now this one, if you have not watched the last lectures, will make no sense to you. This is the logistic growth model. This is 100% on your test. You need to understand how to do these steps. When you watch the lecture video, you'll see this top number, the 194 is carrying capacity. You will see that top number divided by 2 is the inflection point. That's where it is growing the fastest. And this just shows the steps of how to solve for time based on where it's growing the fastest. All right, question number 9, we got a fish farm. I look at this and that looks like logistic growth again. Number 9, it looks like, oh, same thing, another example of number 9. Yep, sorry I'm flipping, I just want to make sure they're different. This is just a second example of question number 9. All right, give you more practice. Question number 10, hey, it's logistic growth again. So I can see initially, I plug in 0. I see here how many people have heard after 5 days. I just plug in 5. What this is saying is if we let t get really big, and you should plug in like a billion, right, a gazillion, you will see that we are going to hit carrying capacity, which is our maximum number of people that know the rimmer. All right, lecture. And question 11 is based on lecture 14. I kind of mentioned this on a problem earlier. This is the surge function. Yes, you can waste your time and work this out with a product rule. You will get the same answer, or you will learn how to use the 1/b to get your answer very quickly. And then you just simply plug this value in to get the peak concentration. All right, I know that was fast and furious, but of course you can pause this. If these are different than yours, I welcome you to rework mine first before you work yours, because again, that just gives you more practice. Peace.